Hello students. In the previous two videos on trigonometric functions, we had discussed the key concepts and the related examples based on that. In today's video, we are going to discuss the type of questions asked in JEE with easy solutions to them. So watch the video till the end. Example 1. A vertical pole consists of two parts, the lower part being 1/3 of the whole. At a point in the horizontal plane through the base of the pole and distance 20 meters from it, the upper part of the pole subtends an angle whose tangent is half. Find the possible heights of the pole. Let us understand this with the help of the diagram. Suppose the total height of the pole is h. So the lower part is 1/3 means h by 3 and the upper part is 2h by 3. Now it is given that the angle which it makes with the upper part, let that angle be theta. So it is given that tangent of it means tan theta is equal to half. And let the angle which it makes with the lower part be alpha. So what is given? H is the height and tan theta is half. We know that tan theta is opposite side upon adjacent side. So now the total angle is alpha plus theta. So tan of alpha plus theta is opposite side which is h upon adjacent side distance given is 20. So tan alpha plus theta is equal to h by 20. Also alpha is the angle which it makes with the lower part. So tan alpha is, what is the lower part? H by 3 and the base is 20. So opposite side h by 3 upon 20. Which gives tan alpha is equal to h by 60. Now we have a formula tan a plus b is equal to tan a plus tan b upon 1 minus tan a tan b. So let us use that formula for tan of alpha plus theta. Tan of alpha plus theta is tan alpha plus tan theta upon 1 minus tan alpha tan theta. And this is equal to h by 20. We know this is equal to h by 20. So now putting the values, h by 20 is equal to, what is tan alpha? H by 60. And what is tan theta? Half. So we put these values and we get a quadratic equation. So after solving this quadratic equation, we get h is equal to 60 or h is equal to 20. So the possible height of the pole can be either 60 meter or 20 meter. Example 2. Find the value of sine 18 degree. Remember, sine 18 degree value is used in many examples. So over here theta which is given is 18 degree. So phi theta will be 90 degree. Phi theta is 2 theta plus 3 theta. So we have 2 theta plus 3 theta is equal to 90 degree, which gives 2 theta is equal to 90 degree minus 3 theta. Taking sine on both the sides, sine 2 theta is equal to sine of 90 degree minus 3 theta. But we know sine of 90 degree means pi by 2. So sine pi by 2 minus x. Again remember, when you have pi by 2 the function changes. If you have pi, it doesn't change. Sine pi by 2 minus x is cos x. So sine of 90 degree minus 3 theta is nothing but cos of 3 theta. But sine 2 theta, we have a formula is equal to 2 sine theta cos theta. And we have another formula for cos 3 theta. Cos 3 theta is 4 cos cube theta minus 3 cos theta. So now sine 2 theta will be, we have sine 2 theta is equal to cos 3 theta. So what we have is putting the formulas. 2 sine theta cos theta is equal to 4 cos cube theta minus 3 cos theta. Let this be equation 1. Now divide this equation by cos theta. Why we can divide? Because we know it is not equal to 0 in the first quadrant. Cos 18 degree is not equal to 0. So by dividing by cos theta, we have 2 sine theta is equal to 4 cos square theta minus 3. Now to make it in one particular trigonometric function, let us convert cos to sine. So what we have is, instead of cos square, we can write 1 minus sine square, because sine square plus cos square is 1. So now we have 2 sine theta is equal to 1 minus 4 sine square theta after simplification. So 2 sine theta is equal to 1 minus 4 sine square theta, or 4 sine square theta plus 2 sine theta minus 1 equal to 0. Now this is a quadratic equation in sine theta. We know that if we have a quadratic equation ax square plus bx plus c, then the roots are given by minus b plus or minus root of delta, which is root of b square minus 4ac upon 2a. So let us apply this to our quadratic equation. So now if we apply the formula for finding the roots for quadratic equation to our equation 4 sin square theta plus 2 sin theta minus 1 equal to 0, we get sin theta is equal to minus b means minus 2 plus or minus root of b square minus 4ac means 4 plus 16 upon 2a, which is 8. So ultimately when you simplify this, you get the value as sin 18 degree as root 5 minus 1 upon 4. And since 18 degree lies in the first quadrant, so sin is always positive. So we only take the positive value from this. So sin 18 degree is equal to root 5 minus 1 by 4. Now please remember this value of sin 18 degree, because in some examples you directly can use the value of sin 18 degree. Next example. Find the value of 2 sin 12 degree minus sin 72 degree. Remember, this type of examples are asked many times in JEE, and you should know the specific way of solving it. So now what we are given is 2 sin 12 degree minus sin 72 degree. Now sin 12 degree, what I am doing is 2 sin 12 degree, we can write sin 12 degree plus sin 12 degree minus sin 72 degree. So now let us combine sin 12 degree minus sin 72 degree. We have a formula sin x minus sin y is 2 cos sin. So now sin 12 degree plus sin 12 degree minus sin 72 degree, by applying the above formula we get 2 cos 12 plus 72 by 2 degree and 12 minus 72 by 2 degree. So ultimately we get sin 12 degree plus 2 cos 42 degree and sin minus 30 degree. We know sin of minus x is minus sin x. So now this will give us sin 12 degree minus 2 cos 42 degree and sin 30 degree is half. So into half. Sin 12 degree minus cos 42 degree. So now again cos 42 degree. So cos 42 degree can be written as sin of 90 degree minus 42 degree, because sin of pi by 2 minus theta will give you cos theta. Correct? So sin of 12 degree minus sin of 90 minus 42 degree, which is equal to sin of 12 degree minus sin 48 degree. Again sin minus sin formula we apply. Sin minus sin is 2 cos sin. So this is 2 cos 12 plus 48 upon 2 degree and 12 minus 48 upon 2 degree. Again over here sin of minus theta is minus sin theta. So this is equal to 2 cos 30 degree sin minus 18 degree, or minus 2 sin of cos 30 degree into sin 18 degree. Now as I told you in the previous example, we had found sin 18 degree. So we directly put the value over here, and cos 30 degree we know it is root 3 by 2. So putting the values we get minus root 3 root 5 minus 1 by 4, or in simplified form you can also write another form, you can also write root 3 into 1 minus root 5 upon 4. Example 4. If cos x plus y is equal to 3 by 5, sin x minus y is 5 by 13, x and y lie between 0 and pi by 4, then find the value of tan 2x. Now remember, in these type of examples, first of all always determine in which quadrant your required angle lies. Since x and y lie between 0 and pi by 4, x plus y and x minus y, they will also lie between 0 and pi by 2. So that means in the first quadrant. Now we have cos square plus sin square is equal to 1. We are given the value of cos x plus y. So sin x plus y will be root of 1 minus cos square x plus y. So putting the values we get sin x plus y is equal to 4 by 5. Similarly for cos x minus y. Cos x minus y is root of 1 minus sin square x minus y. Putting the given value we get 12 by 13. So now what is tan? Sin upon cos. So tan x plus y is sin x plus y upon cos x plus y, which is 4 by 3. And similarly tan x minus y is 5 by 12. Why we are finding the tan values? Because we want to find tan 2x. Now we have a formula for tan a plus b. Tan a plus b is tan a plus tan b upon 1 minus tan a tan b. Now again you should understand by looking at the example why we are doing this, because 2x can be written as x plus y plus x minus y. We want to use the values which we have found out. So tan 2x we will write as tan of x plus y plus x minus y. Using the formula, this is equal to tan x plus y plus tan x minus y upon 1 minus tan x plus y tan x minus y. Now it is simple, just put the values from the first equation. We get tan 2x as 63 by 16 on simplification. Example 5. If sin theta plus cos theta is equal to half, find the value of 16 into sin 2 theta plus cos 4 theta plus sin 6 theta. Now since sin theta plus cos theta is given and we have the identity sin square plus cos square is equal to 1, we should get an idea that we have to square both the sides. So sin theta plus cos theta whole square is equal to half square, which is 1 by 4. But sin square plus cos square is 1. So 1 plus 2 sin theta cos theta is equal to 1 by 4. So 2 sin theta cos theta is equal to 1 by 4 minus 1 or minus 3 by 4. But what is 2 sin theta cos theta? Sin 2 theta. So we get sin 2 theta is equal to minus 3 by 4. Let this be 1, equation 1. What we need is 16 into sin 2 theta plus cos 4 theta plus sin 6 theta. Now since we have the value of sin 2 theta, what we will do is we will try to convert the whole equation in the form of sin 2 theta. So now over here we have cos 2x is equal to 1 minus 2 sin square x. So cos 4 theta is equal to 1 minus 2 sin square 2 theta. And similarly we have a formula for sin 3x, which is equal to 3 sin x minus 4 sin cube x. So sin 6 theta means over here x is 2 theta. So sin 6 theta is equal to 3 sin 2 theta minus 4 sin cube 2 theta. You will have to remember all the identities. So now putting the values of sin 2 theta from the equation 1 and simplifying the left hand side, we get the answer as minus 23. Example 6. If cos x plus cos y minus cos of x plus y is equal to 3 by 2, x and y are between 0 and pi, find the value of sin x plus cos x. This example can also be asked as you have to show that in this case x is equal to y. And then you can obtain actually the value of sin x plus cos y. Now first of all, remember we have an identity cos plus cos is equal to 2 cos cos. So cos x plus cos y is equal to 2 cos x plus y by 2 into cos x minus y by 2. Now it is given to us cos x plus cos y minus cos of x plus y is 3 by 2. So now cos x plus cos y, for this we use the above formula. So we get this equal to 2 cos x plus y by 2 into cos x minus y by 2 minus cos x plus y is equal to 3 by 2. Now we also have an formula cos 2x is 2 cos square x minus 1. So 2 cos x plus y by 2 into cos x minus y by 2, and cos x plus y we will write it as 2 cos square x plus y by 2 plus 1, which is equal to 3 by 2. So now over here y plus, because minus minus will become plus. So now this equation on simplification we get 2 cos x plus y by 2 into cos x minus y by 2 minus 2 cos square x plus y by 2 is equal to 3 by 2 minus 1, which is half. Remember to convert our angle x plus y into x plus y by 2, we have used this formula so that we get it in the same terms. So now what you have is 4 cos x plus y by 2 into cos x minus y by 2 minus 4 cos square x plus y by 2 minus 1 equal to 0. What we are doing is we are just multiplying by 2 so that the right hand side half gets converted to 1 and we can have a quadratic equation, proper quadratic equation. So now over here in this equation, what is the equation? 4 cos x plus y by 2 into cos x minus y by 2 minus 4 cos square x plus y by 2 minus 1 equal to 0. So over here, suppose our angle cos x plus y by 2 is some p, that means it is some variable p, then our equation is 4p into cos of x minus y by 2 minus 4p square minus 1 equal to 0. Remember, why we are doing this is we want to convert this into a quadratic equation, correct? So now this quadratic equation is 4p square minus 4p cos of x minus y by 2 plus 1 equal to 0. In p, it is a quadratic equation variable p. Now the roots of quadratic equation, you know, x square plus bx plus c is equal to 0 is a quadratic equation, and for the roots to be real, what should we have? Delta or b square minus 4ac should be greater than or equal to 0. Now our quadratic equation is 4p square minus 4p into cos x minus y by 2 plus 1 equal to 0. And for the roots to be real, b square minus 4ac should be greater than or equal to 0. What is b over here? b is 4 into cos x minus y by 2. So b square minus 4ac is 16 cos square x minus y by 2 minus 16 should be greater than or equal to 0. We take out 16 common, so basically it is cos square x minus y by 2 minus 1 should be greater than or equal to 0, or cos square x minus 1 by 2 should be greater than or equal to 1. Now we know that the range for cos is minus 1 to 1. So greater than or equal to 1, greater than 1 is not possible. So cos square x minus y by 2 should be equal to 1, or cos x minus y by 2 should be equal to 1. When is cos 1? We know cos of 0 is 1. When the angle is 0, we have cos of 0 as 1. So x minus y by 2 should be equal to 0. So simplifying, what we get is x equal to y. So first thing what we have obtained is, in this case, x equal to y. Now what do we want to find? Sin x plus cos x. So now what we do is cos x plus cos y minus cos x plus y equal to 3 by 2. This is given to us. In this equation we put x equal to y. So what we get is 2 cos x minus cos 2x is equal to 3 by 2. But cos 2x is 2 cos square x minus 1. So now we get an whole equation in terms of cos x. What is the equation? 4 cos square x minus 4 cos x plus 1 equal to 0. And what is this? This is 2 cos x minus 1 whole square, which is equal to 0, or 2 cos x equal to 1, which gives cos x is equal to half. When is cos half? When the angle is 60 degree. Cos 60 degree is half. So we get the value of x as 60 degree. When the angle is 60 degree, what is sin 60 degree? Root 3 by 2. So now what we want is sin x plus cos x. Putting the values, we get half plus root 3 by 2, or root 3 plus 1 divided by 2. This is the value of sin x plus cos x. So this is how this example is solved. Example 7. If sin x is equal to minus 3 by 5, x lies between pi and 3 pi by 2, then find the value of 80 into tan square x minus cos x. Now see, in this case, what we are given is our angle lies between pi and 3 pi by 2, means in the third quadrant. Now first of all, sin x is minus 3 by 5, and we have cos square plus sin square is equal to 1. So what is cos x? Cos x is root of 1 minus sin square x. So that is plus or minus 4 by 5. But again, as I said, our angle lies in the third quadrant. So in the third quadrant, ASTC, in the third quadrant, cos is negative, correct? Only tan is positive, cos is negative. So cos x will be minus 4 by 5. Sin x is minus 3 by 5, cos x is minus 4 by 5. So what is tan x? Sin upon cos, which is 3 by 4. Why we are doing this? Because we want tan x value. So now our left hand side is 8 into tan square x minus cos x. So putting the value of tan x and cos x, on simplification we get it equal to 109. We are doing different type of examples which were asked in JEE. Next example, suppose theta belongs to 0 to pi by 4 and theta is a solution of the equation 4 cos theta minus 3 sin theta equal to 1. Then find the value of cos theta. So now we have over here cos and sin is given. So we'll use the identity sin square plus cos square is equal to 1. Now 4 cos theta minus 3 sin theta is equal to 1 is given to us. So what will be sin theta? Making sin theta subject of formula, we get sin theta equal to 4 cos theta minus 1 upon 3. Why we do this? Because we try to convert it in the same variable. So sin square theta will be 4 cos theta minus 1 by 3 whole square plus cos square theta equal to 1. Simplification, we get 25 cos square theta minus 8 cos theta minus 8 equal to 0. So what is this? This is a quadratic equation, and we know ax square plus bx plus c is a quadratic equation, and its roots are given by minus b plus or minus root of b square minus 4ac upon 2a. So now this is a quadratic equation in the variable cos theta. So cos theta is equal to, putting the values over here, 8 plus or minus, when you simplify b square minus 4ac, you get it 864 upon 2a, which is 50. Simplification, on simplification we get 4 plus or minus 6 root 6 upon 25. Right? Now here cos theta is in the first quadrant. 0 and pi by 4 means in the first quadrant. In first quadrant everything is positive. So 4 minus 6 root 6 is not possible. So the only possible value for cos theta is 4 plus 6 root 6 upon 25. So cos theta is 4 plus 6 root 6 upon 25. Now see, in JEE options are given for answers. So suppose here the answer is 4 plus 6 root 6 upon 25. Suppose that is not given in any of the options. We try to convert this in one of the forms which suits our options. So now cos theta is 4 plus 6 root 6 upon 25. Now what you do is you take out common, so it is 2 into bracket 2 plus 3 root 6 upon 25. Now you multiply by the conjugate, so you get it 2 into 3 root 6 plus 2, multiply and divide by 3 root 6 minus 2. So now a minus b into a plus b is a square minus b square. So 3 root 6 plus 2 into 3 root 6 minus 2 is 54 minus 4. So on simplification you get cos theta as 4 upon 3 root 6 minus 2. So this can also be one of the options which is given to us. So on cos theta can also be written in this case as 4 upon 3 root 6 minus 2. We have done examples which were asked in JEE from trigonometric functions class 11. Generally examples based on this pattern are asked. So practice this type of examples. Do like and share the video, and don't forget to subscribe to MathsPractice. Thank you.